Hello out there, welcome to this tutorial on application of differentiation. We look at increasing and decreasing functions in this video. Check the description section of this video on our YouTube channel to get our first video on increasing and decreasing functions from graphs. So we look at definition. The function y equal to f of x is increasing at a given interval if the y dx is greater than 0, that is, the gradient is positive at the interval. So the function y equal to f of x is decreasing at a given interval if the y dx is less than 0, that is, the gradient is negative at the interval. So we are going to look at some problems. So starting from problem 1, find the range of values of x, that is the open interval for which each of the following functions is increasing. So starting from problem A, we have y equal to x squared plus 4x. Now we are going to find the y dx. So the y dx equal to 2x, the derivative of x squared there is 2x, and the derivative of this 4x is 4, so plus 4. Since we are looking for the interval for which the function is increasing, it means the derivative is greater than 0, it's positive. So we say if the y dx is greater than 0, then 2x plus 4 is greater than 0. Solving this inequality, we have x is greater than negative 2, and we can state it as open interval as negative 2 comma positive infinity. That is, for x is negative 1, 0, 1, 2, 3 up till positive infinity. This interval, the function is increasing. So we go to problem 1b. For problem 1b, again we find the derivative of this function with respect to x. That's the y dx is equal to 2 times 3 gives 6, reduce the power by 1, we have 6x, and the derivative of negative 2x is negative 2. Since we are looking for the interval for which the function is increasing, so we say if the y dx is greater than 0, then 6x minus 2 is greater than 0. Taking this negative 2 to the right hand side, it becomes positive, dividing by 6x is greater than 1 over 3, which can also be stated as 1 over 3 comma positive infinity. Then we now go to problem 1c. For problem 1c, y equal to x cubed over 3 minus 5x squared over 2 plus 6x minus 8. We find the first derivative again, that is the y dx is equal to, we are multiplying the whole thing by this power, which is 3, so the 3 we go, and reducing the power by 1, we have x squared minus 5x plus x. If you find the derivative of this 5x squared over 2, it gives 5x. Derivative of 6x is 6. Derivative of a constant is 0. Since we are out for the interval for which the function is increasing, so the y dx is greater than 0. If the y dx is greater than 0, then x squared minus 5x plus 6 is greater than 0. We are going to use the graphical method to solve this inequality. We have videos on these quadratic inequalities. Check our videos on our channel for a package on these quadratic inequalities. So we factorizing this, we have x minus 2 into x minus 3 greater than 0. We look at x-intercept, that is the zeros of this inequalities. So we now have x is equal to 2, x is equal to 3. So these are the zeros where we'll be having our x-intercept. Then we now go for our y-intercept. For our y-intercept, x is 0, so we'll be left with 6. So that will give you 0, 6. Now, sketching the curve, we have the x-axis and the y-axis. The origin, we get to the x-axis. What we have there is 2 and 3. On the y-intercept, we have a 6. So joining these 3 points, we have something like this. Since the inequality symbol is greater than 0, what we have is the upper part of x-axis. That's the positive side of y, which means we are going to shade the wings of this graph. Anything above the x-axis gives the values of x which satisfy the inequality we have here. So stating this now, which means x is less than 2, that is x is 1, 0, -1, -2, -3. So this interval, it means the function is increasing, and from 3 to the right up till infinity, the function is also increasing. So we are going to find the union of the intervals. So that is going to be union x is greater than 3. Expressing this as open interval, we have a -infinity, 2 union 3, positive infinity. And that is the end of solution to problem 1. We go to problem 2. For problem 2, find the range of values of x, the open interval for which each of the following functions is decreasing. We start from the a part of the problem. We have y equal to 6x squared minus 8. So finding the derivative of this function, the y dx is 12x minus 8. If you find the derivative of 6x squared, it gives you 12x, and the derivative of 8x is 8. Since we are looking for the interval for which the function is decreasing, we say the gradient is negative. So that is, if the y dx is less than 0, then 12x minus 8 is less than 0. Solving this, take this to the right hand side, and dividing by 12, we have x is less than 2/3. And stating it as an open interval, we have -infinity, 2/3. This is the range of values of x for which the function in problem 2a is decreasing. So we go to problem B. For problem B, again, we are going to find the first derivative of the function. So that is the y dx is 2x plus 6. So since we are looking for the interval for which the function is decreasing, it means the y dx is less than 0. So if the y dx is less than 0, then 2x plus 6 is less than 0. Taking this to this side and dividing by 2, we have x is less than -3. And expressing it as an open interval, we have it as -infinity, -3. And that is the end of solution to problem B. So we go to C. For problem 2C, we are also going to find the derivative. So we have the y dx. Derivative of a constant is 0. Derivative of 6x is 6. Finding the derivative of x squared over 2, we have a -x and minus x squared. Now we find the interval from here. Since the interval we are looking for is for decreasing function, it means the first derivative is less than 0. So if the y dx is less than 0, then 6 minus x squared is less than 0. And factorizing, we have 2 minus x into x plus 3 less than 0. So we get the zeros, since we are going to use the graphical method to solve this inequality. So we have the zeros as x is equal to 2 and x is negative 3. Then we also find the y-intercept. The y-intercept is when x is 0. So put this as 0. So the y-intercept will be 6. So sketching the curve, we have x, this is y-axis, this is the origin, the negative 3, we have a 2, and this is 6. So joining these 3 points, we have something like this. And since it is less than 0, it is below the x-axis, that is the negative side of y. And as a result of that, we are going to shade again the wings. So we shade the wings here, so that the two intervals now represent the region or the interval for which the function is decreasing. So stating this, we have a x less than negative 3 union x greater than 2. If you are stating it as an open interval, we have it as negative infinity, negative 3 union 2, positive infinity. And that is the end of solution to problem 2. This is the highest we can take in this tutorial. Check the description section of this video on our YouTube channel for more videos on application of differentiation. Also, you see the increasing and decreasing functions using the graphical method. Until we come your way again, goodbye.